Good evening, everyone. Welcome to the session 17 of JEE Physics. The chapter is current electricity, and the question which I have taken for this session is written on this board. This is a very easy question. However, I have taken this question for this session because it involves the concept which we have studied in the chapter of heat and thermodynamics. And because of that reason, I have taken this question for this session. Now, in the question here, there is a wire of length L, and there are three identical cells which are connected in series. And these cells have got negligible internal resistance. Due to the current which is flowing in this wire, the temperature of the wire is raised by delta T in a time interval T. Now, a number of similar cells are connected in series with a wire of the same material and same cross-sectional area but of length 2L. The temperature of the wire is raised by the same delta T in the same time interval, that is T. So we have to find the value of N, that is the number of cells in this combination. So we know that the resistance of the wire is given by R is equal to rho L divided by A, where rho is the resistivity of a material, L is the length of the wire, and A is the cross-sectional area. So in the first case, say the resistance of the wire is equal to R1. So I will be writing as R1 is equal to rho L divided by A, where A is the area of cross-section of this wire, and L is the length of this wire, and rho is the resistivity of the material of this wire. Now in the second case here, when there are n number of similar cells connected in series with a wire of the same material and same cross-section area, that is A. So in that case, let us say the resistance is R2. That is, R2 is the resistance in the second case, and then it will be equal to rho. The length is equal to 2 times of L divided by A, where A is the area of cross-section, because the area of the cross-section in both the cases are the same. So since in the first case I have taken it as A, so in the second case it will be also A. Now the resistivity will also remain the same, because both these wires are made of the same material. So R1 is equal to rho L upon A, and R2 is equal to 2 times of rho L upon A, or we can say that R2 is equal to 2 times of R1. So we can write these results here, that is R2 is equal to R1 is equal to 2 times of R1. Now, here in the first case, three identical cells of negligible resistance are connected in series. So let the potential difference, here I am writing this potential difference as PD. So let the potential difference across each cell is equal to V. Then it implies that the effective potential difference in the first case will be equal to V plus V plus V, because the potential difference in the series circuit is equal, that is, the effective potential difference in a series circuit is equal to the sum of the potential difference across each cell. So here, if we have taken the potential difference across each cell as V, then the effective potential difference in the first case will be equal to 3V. Okay, now if I take this effective potential difference as, let's say, V1, so I will be writing that the potential difference in the first case, that is the effective potential difference in the first case will be equal to 3 times of V, where V is the potential this difference across each cell. Now okay, now let us calculate the mass of the wire in the first case and in the second case. Then let us say the mass of the wire in the first case, let's say m1. This will be equal, mass is equal to density into volume. So let us say the density of the wire is D into volume. That is equal to D. Volume is what? That is equal to area of cross section into the length of the wire. So area of cross section we have taken as L, and the length of the wire is equal to L. So the mass of the wire in the first case is equal to m1, and the mass of the wire, say in the second case, say it is m2. This will be equal to density of the material into volume. Volume is what? Area of cross section into length. Length is equal to 2 times of L, which is equal to 2 times D A L. ठीक है, so I will be writing it. मैं यहाँ पे लिख लेता हूँ कि that is m1, that is the mass of the wire in the first case is equal to DAL, and the mass of the wire in the second case is equal to 2 times of m1. ठीक है, because here this DAL is equal to m1, so I have written that the mass of the wire in the second case is equal to 2 times of m1. Now, the heat produced in the electric circuit is given by heat produced in an electric circuit is given by H is equal to V square upon R into T. ठीक है, where T is the time, V is this is the potential difference, and R is the resistance. So in the first case, that is the heat produced in the first case, let us say it is H1. So in the first case, the effective potential difference was equal to 3 into V. 3 into V whole square divided by R1, where R1 is the resistance of the wire in the first case, which we have taken. So this is equal to 9V square upon R1. This is the heat produced in the wire in the first case. That is the wire in the wire of length L, and which consists of these 3 identical cells in series. So I will be, so H1 is equal to 9V square upon R1, and so I will be writing this the value of this H1 here, that is H1 is equal to 9V square divided by R1. Similarly, into T, ठीक है, so H1 is equal to into T, so this is equal to 9V square divided by R1 into T. So ये हो जाएगा मेरा into T. Now H2 क्या हो जाएगा? H2 will be equal to, now in the second case there are n similar cells which are connected in series. So the effective potential difference in the second case will be equal to n into V, because these cells are similar. So in I have taken that is the potential difference across each cell is equal to V. So in the second case, since there are n cells which are connected in series, so effective potential difference will be equal to n into V. So this will be equal to n into V ka whole square divided by the resistance of this wire, which is equal to R2, and R2 was equal to 2 times of R1 into T. Okay? So this is the heat produced in the wire consisting of n similar cells and of length 2L, and this is the heat produced in the first wire of length L consisting of 3 identical cells. Now, we also know that we have studied in the chapter of heat and thermodynamics that the heat produced heat produced in a substance. Heat produced in a substance uh, when the temperature is raised by delta T is given by Q is equal to M into S into delta T, where delta T is the temperature difference, S is the specific heat of that substance, and M is the mass. So I will be using this formula in order to solve this question. That is Q is equal to Ms delta T. That is, so in the first case, H1 is equal to 9 V whole square into T divided by R1, and this will be equal to Q, that is Q is equal to Ms delta T. M is the mass. Now the mass of in the first case is equal to DAL into the specific heat of that wire into delta T. And in the second case, that is when the heat produced in the second case, that is when there are n number of similar cells connected in series uh, with a wire of the same material and having the same cross section area, that is A. So in that case, the heat produced is equal to n square V square into T divided by 2 times of R1, which is equal to mass in this case is equal to 2 times of D A L in DAL S delta T. See, this is the mass. The mass in the second case, that is the mass of the wire in the second case, is equal to 2 times of DAL. So 2 times of DAL into the specific heat of that wire into the temperature difference. So I have got these two equations now, and with the help of these two equations, we will be able to find the value of n. Now what I will be doing is, I will be dividing both these equations, that is 9V square upon T upon R1 is equal to DAL S delta T, and the second equation is n square V square into T divided by 2R1 is equal to 2 times of DAL into S into delta T. So if I divide both these equations on the left hand side and the right hand side, then what I will be getting is that is 9V square T upon R1. This 2R1 will go in 2R1, and this will be n square V square into T, and this is equal to this DALS and delta T. DALS delta T. They will cancel out. So I will be just left with 1 by 2. And I have got this equation. Just let us say this is this equation by dividing this equation. That is, let's say this is the equation number 1 and this is the equation number 2. So what I have done is that I have divided the equation number 1 and equation number 2 on the left hand side and on the right hand side. So by dividing the when we have divided these two equations on the left hand side, that is like this, and on the right hand side we finally got this equation, that is 9V square into T divided by R1. ये जो 2R1 is, that will go into the numerator and this will be in the denominator, and this will cancel out this DAL S delta T, this entire, it will get cancelled out, so I will be left with 1 by 2. So this is equal to, it implies that now here t will cancel out, v square will also cancel out, r1 will also cancel out. So what we are getting is n square is equal to 36, or n will be equal to under root of 36, that is equal to 6. Okay. So the correct answer in this case will be equal to, is the second option, that is B, because B is the correct answer because n is equal to 6. So our correct answer is the option B. So now this question was, it was an easy question. The only thing is that in this question we have used the concept, or we have used the equation of the quantity of heat required to raise the temperature of a substance by the temperature difference of delta T, which we have studied in the temperature of heat and thermodynamics. So by using that that concept or that equation, we were able to solve this question, and the number of cells which are required to be connected in series with a wire of the same material and same cross-sectional area A, but of length 2L, okay, will be equal to 6. And here the temperature difference of the wire will be the same, that is delta T, in the same time interval, say T. So thank you very much for joining this session, and I hope you have understood what I have tried to explain here. And in the session number 18, I will be continuing with the same chapter. So thank you very much and have a nice day. Bye.